Hello, this lecture is a tutorial for setting up Program Mark for the Known Fate lab exercise. To begin, click File, Preferences, and make sure to display the -2 log likelihood in the results browser. Click OK. Go back to the File menu, click New Project, the Known Fates data type, and provide a title for the dataset. Next, we will select an encounter histories file. Click to select the file. We will choose the Black Duck 2 group no covariate input file. Click Open. One thing to keep in mind is Program Mark wants to name the results file after the input file. So if you have multiple results files for each input file, you may want to edit the results file name. And here I added a number after the file name to prevent Mark from overwriting the previous file. From the lab exercise, there were 8 encounter occasions, so we can use the radio button to select 8 occasions. There were 2 attribute groups, and we can go up here to view the encounter histories file. And the caption at the top says, Group 1 are the subadults, and Group 2 are the adults. The first covariate column corresponds to the subadults, and the second column corresponds to the adults. Now we can enter the group labels. Group 1 are the subadults, and Group 2 are the adults. Click OK, and click OK again. Mark wants to create a results database with this file name. Click OK, and we can close down the parameter index matrix to start. Go to the menu bar, click PIM, and Parameter Index Chart. The parameter index chart may be familiar from the lecture material. The y-axis contains the parameter types, and the known fate model has a single parameter type, survival S. And here there are 2 groups, adults and subadults. The x-axis contains the parameter indices, and parameters 1 through 8 correspond to the survival parameters for the subadults, and parameters 9 through 16 correspond to the survival parameters for the adults. So this is model group times time from the lab exercise, and now we will go over how to go about constraining the parameter index matrix to represent the different models in the lab exercise. Let's constrain this model to a time-specific model with no differences in survival for the adults and subadults. To do this, we can click and drag the block of parameters for the adults and make them equal to the subadults. Now we have a time-specific survival model with a parameter for each time occasion with no differences in survival for the adults and subadults. Let's go back to that multiplicative model by selecting Initial, All, and Make All Different, and then renumber with no overlap. Now let's constrain this model to a model with constant survival for the time occasions with differences in survival for the groups. To do this, we can right-click on the parameter block for the adults and click Constant, and do the same for the subadults. Right-click, click Constant, and we can either click and drag or renumber with no overlap. Now we have a model where survival is constant across the time occasions, but survival is different for the groups. let's get back to that multiplicative model by clicking Initial, All, and Make All Different, Renumber with no overlap. And let's run this model. We can close the parameter index chart, then go to the menu bar, click Run, Current Model. Let's name the model using this notation, survival group times time. And for the purpose of this exercise, make sure the SignLink function is selected, then click OK to run. Use an identity design matrix since none was specified. Click Yes. Append this model's output to the database. Click Yes. And the group times time model was added to the results browser. Now let's take a look at the model parameters. The real parameters are found here. Here are the estimates of survival on the probability scale with their standard errors and confidence intervals. Notice several of the estimates are estimated at 1 with very small standard errors. Now let's take a look at the beta parameter estimates. Here are the beta estimates estimated on the SignLink scale. Notice that all the betas and standard errors are estimated here with the SignLink. We can download the results by going to the menu bar, click Output, and here let's download the table of model results. Copy to Excel. The results are downloaded, and we can save this file to our directory. We can do the same for the parameter estimates. Go to the menu bar, click Output, Specific Model Output, Parameter Estimates, and let's choose the beta estimates and copy beta estimate standard errors and confidence intervals to Excel. And the results are downloaded, and we can download this file to our directory. Now let's run another model. Let's go to the menu bar, click the PIM parameter index chart. Here's the familiar parameter index matrix for the model group times time. We can close the PIM chart, go to the menu bar, click Run, Current Model. Now instead of the SignLink function, let's run the logistic model using the logitlink function. Remember from the lecture material that choosing the logitlink will run a logistic survival model. Let's add a logit descriptor to the model name. Then click OK to run. Use an identity matrix, yes. Append the output to the database, yes. And the logistic survival model was added to the results browser. There are a few things we can take away from this model selection table. Notice that the number of parameters for the logit model was 10, whereas the number of parameters were 16 for the SignLink model, and the AIC values also differed for these two models. Note that the -2 log likelihood is identical for both models, as well as the deviance. So let's take a look at the parameter estimates to see what could be going on here. The reals can be found here, and here are the survival estimates on the probability scale. And just like in the SignLink model, we see some of the estimates are estimated at 1 with very small standard errors. Now let's look at the beta parameters. Here are the beta estimates estimated on the Logit-Link scale. And here we see a difference from the SignLink model, where some of the standard errors for the beta estimates are either very small or very large. This is an indication that the parameters did not converge and were not estimated well. The Logit-Link model has trouble with parameter estimates when they are near the boundary of 0 or 1. And now that we look back at this model selection table, the fewer number of parameters resulted in a different estimate of AIC. The take-home message here is when the real parameters are near the boundary of 0 or 1, the SignLink function can be used to estimate model parameters and achieve valid model selection. However, the logistic model is often more appropriate for covariate models. That concludes the tutorial. Thanks for your attention.